Welcome to Sujitra Statistics classes. Today we are going to discuss moment generating function, characteristic function and mode of a binomial distribution. Moment generating function. When x follows b and p, there is binomial distribution with the parameter n and p, then p of x equal to small x is f of x equal to ncx p raised to x q raised to n minus x. Then mxt is equal to expectation of e raised to tx, that is summation e raised to tx fx. Then expanding like this, combining e raised to tx and p raised to x, we will get p e raised to t all raised to x. Therefore, this can be rewritten as q plus p e raised to t all raised to n. Therefore, moment generating function for binomial distribution mxt equal to q plus p e raised to t all raised to n. Raw moments will obtain by successive differentiation of mxt and putting t equal to 0. That is mu r dash is equal to d raised to r mxt by dt raised to r at t equal to 0. Therefore, mu1 dash is d by dt of mxt at t equal to 0. So, we will get mu1 dash is equal to np. Then mu2 dash is equal to d square mxt by dt square at t equal to 0. That is d by dt of dmxt by dt at t equal to 0. Proceeding, you will get mu2 dash is equal to n into n minus 1 p square plus np. And mu2 equal to mu2 dash minus mu1 dash whole square, which is equal to npq by applying the value of mu2 dash and mu1 dash. Then mu3 dash is d cube mxt by dt cube at t equal to 0, that is d by dt of d square mxt by dt square at t equal to 0. And we know what is mu3 in terms of mu3 dash, mu2 dash and mu1 dash. Then mu3 equal to npq into q minus p, applying the values. Similarly, we can find mu4 dash using the equation for mu4 from the raw moments. We will get mu4 is equal to 3 into npq square plus npq into 1 minus 6pq. Now we are going to discuss about the additive property of binomial distribution. If x follows b and 1p and y follows b and 2p are two independent random variables, then their sum x plus y follow b n1 plus n2 p. That is, if x is a binomial random variable with parameters n1 and p and y is a binomial random variable with parameter n2 and p, here p is same, x plus y is another binomial with parameter n1 plus n2 and p. When x follows b and 1p, mxt is q plus p raised to t all raised to n1. If y follows b and 2p, then myt is equal to q plus p raised to t all raised to n2. By additive property of moment generating function, if x and y are independent, mx plus yt equal to mxt into myt. That is q plus p raised to t all raised to n1 into q plus p raised to t all raised to n2. that is q plus p raised to t all raised to n1 plus n2, which is the moment generating function of a binomial distribution with the parameters n1 plus n2 p. This can be extended to any number of independent random variables if p is same. If the p is not the same, then x plus y will not be binomial. Now let us move to characteristic function. Phi xt is equal to expectation of e raised to itx, same as that of moment generating function. We will get phi xt equal to q plus p e raised to it all raised to n. Raw moments will obtain by mu r dash is equal to minus I raised to r d raised to r phi xt by dt square at t equal to 0. Then mode of binomial distribution. Mode of a probability distribution is the value of the random variable having maximum probability. If x is the mode of a distribution, fx will be the maximum. That is f of x minus 1 less than or equal to f of x greater than or equal to f of x plus 1. This can be split into f of x minus 1 less than or equal to f of x and f of x greater than or equal to f of x plus 1. In f of x minus 1 less than or equal to f of x, we have this expression. Then expanding for ncx minus 1 and ncx, we will get this expression. Split q raised to n minus x plus 1 as q into q raised to n minus x. N minus x plus 1 factorial as n minus x plus 1 into n minus x factorial. X factorial as x into x minus 1 factorial. P raised to x as p into p raised to x minus 1. And cancelling the like terms, nx1, nxn get cancelled, x1 factorial and x1 factorial get cancelled, nx factorial and nx factorial get cancelled, p raised to x minus 1 and p raised to x minus 1 get cancelled, and these two get cancelled. Then you will get this expression q by n minus x plus 1 less than or equal to p by q. On simplifying and taking terms containing x to the left side, we will get x less than or equal to n plus 1 p. Let it be inequality number 1. In f of x greater than or equal to f of x plus 1, in the similar manner, we will get x greater than or equal to n plus 1 p minus 1, the inequality number 2. Combining 1 and 2, we are getting n plus 1 p minus 1 less than or equal to x less than or equal to n plus 1 p. Now let us interpret what is the mode of the distribution. So mode, that is x, lies between n plus 1 p minus 1 and n plus 1 p. If n plus 1 into p is an integer, say k, then the mode is at x equal to k and at x equal to k minus 1, that is binomial distribution is bimodal. If n plus 1 into p is not an integer, then the integer part of n plus 1 into p is the mode of the binomial distribution, which is a unimodal distribution. So, things to be clear from this class are how to calculate moment generating function of a binomial distribution, hence deduce the central moments, additive property of binomial distribution, how to find the characteristic function of a binomial distribution, calculate and interpret mode of binomial distribution. Thank you for watching. If this is found to be useful, then like and subscribe Suchitra's statistics classes. Once again, thank you.